So for this problem, you have a 75 milliliter solution of hydrochloric acid with an unknown concentration, and it's titrated to the equivalence point, which is pretty much just the point at which either a precipitate is formed or the solution changes color, with 27.3 milliliters of 0.157 molar calcium hydroxide. What was the concentration of HCl in the original solution? So you're looking for hydrochloric acid, the concentration at the beginning. So you should start off with the chemical formula, balanced chemical formula. You have HCl plus CaOH2 yields. So usually when you have a hydroxide and an H, you should realize that H2O is going to be one of your products. Also, calcium and chlorine are going to link because of the positive charge on calcium and the negative charge on chlorine. So you have CaCl2 because calcium has a 2+ charge and Cl has a 1- plus H2O. So in order to balance this, you have to see we have 3 H's on this side, 1 Cl, 1 Ca, and 2 O's. On this side you have Ca, 1 Cl2, 2 H's and 1 O. So you could put a 2 right here to get the Cl's equal, and so you have 4 H's on this side, so if you put a 2 right here, you should be balanced. Everything should add up. Alright, and so now you have your balanced equation, so you should draw your diagram to just kind of get an idea of what you're working with. So you have HCl, so you have an H plus and a Cl, hydrogen ion and a chloride ion, and that's in 75 milliliter solution, but you should convert to liters right now because it's just going to help with the calculations later on. Yep, another solution that has Ca plus and 2 hydroxide ions OH minus, and this is 0.0273 liters. It's 27.3, just converted that one to liters too. This one's HCl, this one's CaOH2. So now you kind of have an idea of what you're working with. You're gonna just combine these two solutions and you're looking for the original concentration of HCl. So you were given the volume and the molarity of calcium hydroxide, and when you have that, you should be able to figure out the moles of calcium hydroxide using the molarity equation. Molarity equals moles over volume. So you have 0.157 molar equals moles of CaOH2 over 0.0273 liters of CaOH2. So to get the moles, you have to multiply these two numbers, and that should give you 4.2861 times 10 to the -3 moles of CaOH2. So now you have the moles of that. You can use a molar conversion to find the original moles of hydrochloric acid. So you have 4.2861 times 10 to the -3 moles of CaOH2 times, you see here you have 1 moles of these for every 2 moles of hydrochloric acid, so 1 moles CaOH2 every 2 moles of HCl, and that equals 8.5 722 times 10 to the negative 3 moles of HCl. So now you have the moles of HCl and you have the original volume of HCl, so you should be able to figure out the concentration just by dividing the two numbers. You have 8.5722 times 10 to the negative third moles of HCl divided by 0.075 liters of HCl, and that should give you 0.114296 as your molarity, which is your concentration.